That was a bit much. Hello! Hi, I am Rendle, and I am here to talk to you about how JavaScript happened. And if you want to read into that and how can we stop it from happening again, I'm not going to stop you. But I will just say, because it's easy to bash JavaScript, but this is a saying that I found while I was researching this talk. This is Flon's axiom. There does not now, nor will there ever exist a programming language in which it is the least bit hard to write bad programs. Yes, even Scala. So, with that in mind, let's go back. We go back to the before times, before there were computers, before there were programmers, before there were anything really, silicon chips and transistors and all this sort of stuff, to the 1830s in Britain. And this young lady here, who is Ada Lovelace, and Ada Lovelace was the daughter of the romantic poet and one-man syphilis incubator, Lord Byron. And Ada's mother thought the best thing that she could possibly do for her daughter was to keep her the hell away from her dad, which was probably right. And so she kind of cloistered her and got her tutors in maths and Latin and all the things that young ladies learned in those days. And then when Ada was a bit older, she started going to salons to speak with other intellectuals and learn more things. And at one of those salons, she met Charles Babbage. And Babbage would have built the first computer if he hadn't also probably had ADHD. Because Babbage went to the UK Parliament and he said, give me £500,000 and I will build a machine that can do maths. And so they gave him £500,000, which in those days was a lot of money. And he went off and he got halfway through building his first machine, and then he had a better idea. And so he went back to Parliament and went, give me £1 million and I'll build a better one. And they said, no. And so he started building it with the money that he had left over from the half. And anyway, so he never finished it, but he did show it to Ada. And he also spoke a lot to an Italian chap who wrote a book about the difference engine and the analytical engine. And then Ada was asked if she would like to translate that book into English, and she said yes, and she did. But she also added some of her own notes to it, including this sheet in the background here. And that is a program that you could run on the analytical engine for calculating Bernoulli numbers, whatever the hell those are. And so that is the first programming notation and the first computer program written by Ada Lovelace 120 years before anybody actually invented anything resembling a computer. And then from 1850 to 1940, nothing really happened at all in the world. Just we all slept for those 90 years. And then we woke up and we decided, let's have a war. We haven't had a war for 30 years, we should have another war, that'll be fun. And so we all went off to war and we were shooting at each other, and we needed to send messages to each other to decide what we were going to shoot at next. And so we didn't want the enemy to know what we were going to shoot at next. We had to encrypt those messages. And the Germans did this using one of these. This is an Enigma machine. And the Enigma machine worked by patching cables between those little sockets you can see on the front, and then dropping 4 dials in and setting them all to an initial state. And the initial state changed every day. And there were billions, hundreds of billions of possible combinations. And so the Germans were like, this is uncrackable. Nobody's ever going to be able to guess 1 in hundreds of billions of combinations. But at Bletchley Park in the UK, Alan Turing was working on this. This is a bomb, and this was actually invented by the Polish. And then when Poland got invaded, they kind of shipped the intellectual property to the UK. And so we built a bomb, and this could try hundreds of thousands of combinations very, very quickly. And that, combined with the fact that people always started the day with a weather report, helped us to crack the Enigma code. And The Germans never found out we did that, by the way, and after nobody else, the Canadians and the Americans and the Australians and the New Zealanders, none of them ever found out we'd cracked it either. We didn't tell anybody. What we did do was give loads of Enigma machines to our allies and say, there you go, now we can use this for encrypted communication, so we knew what they were talking about all the time. Yay! However, even the Germans weren't 100% confident in that machine because they had this as well. This is the Lorenz cipher machine. And the Lorenz cipher machine has more possible initial states than there are atoms in the observable universe. It's just a ridiculously big number. And there was no way you could defeat that with just a bomb kind of thing. And so we built this. This was Colossus. And this was built by a chap from the post office who had been working with telephone relays and things. And so this was a programmable computer. This was the world's first programmable computer. And then 1945 came along, the war ended, and we smashed it to pieces and burned all the documents and everything. And it didn't come out that we had built this until well into the 80s or 90s, I think. And so everyone thought that the first programmable computer was this, which was the Eniac, Electronic Numerical Integrator and Computer. And you didn't program this the way we program things today. You programmed it by running patch cables between different points on the front of it. And the men who built it thought that programming it was beneath them, and so they gave that job to women. These were the Eniac programmers: Kay McNulty, Betty Jennings, Betty Snyder, Marilyn Westcott, Fran Blass, and Ruth Lichterman. And not only did they program the Eniac, they also worked out how to program the Eniac because the guys who built it didn't provide them with any kind of manual, and so they just figured it out as they went along. And so that was sort of, it was a configurable computer. You plugged in the patch cables and then you turned it on and it did whatever it did and then you turned it off again. And that was what we had for a while until IBM created the 701, the first mainframe programmable computer, which had memory. You could load programs into memory and you could run them, and then you could load another program into memory and so on. And that was great. And at the time, because we were still sort of planning for the next war, a lot of the things that people were using computers for was things like trajectory calculations. If I put this much gunpowder in a cannon and then explode it, and it's at this angle, how far will the cannonball travel? And, I mean, the equation there looks quite simple, that sort of y is x tangent. I don't know the Greek stuff. It doesn't look simple at all, actually. I haven't got the faintest idea what's going on there. But it looks really, really simple compared to this, which is what you have to translate that into if you want to figure it out on a computer. And so that's machine code, and people had to figure out how to convert tangent and sine and cosine and all these different things into very, very simple single CPU instructions, one after the other. So, 1955, this chap comes along. This is John Backus. And John Backus was walking down the street in Manhattan one day and walked past the IBM building. And in the lobby of the IBM building, they had an IBM 701. And it had lots of flashing lights and things on it. Interesting side note, the flashing lights on those mainframes weren't actually particularly useful. They were mainly there as a marketing tool to make the machines look more interesting. And John Backus went, that looks really, really fun. I'm going to go in there and see if I can get to play on that. And so he went in and said, how do I get to play on that? And they said, you have to work here. And he said, how do I get a job? And they went, well, you go up there and talk to somebody. And so he did, and they gave him a job. And then he found out about the whole machine code thing, and he went, no, I'm not doing that for the rest of my life. Because John Backus, and this is an important point, was lazy. He was a very, very lazy man, and he didn't want to do the work of translating formulas into machine code. Bill Gates once said, I choose a lazy person to do a hard job because a lazy person will find an easy way to do it. And John Backus's life story is effectively finding easier ways to do things. And so he got a team together, and he went to IBM, and he said, we're going to make a language that will translate formulas into machine code. And we're going to call it Formula Translator, or Fortran for short. And they released the specification in 1955, and then they released the actual software, the compiler, in 1957. And this is FizzBuzz in Fortran. Everyone know what FizzBuzz is? 1, 2, fizz, 4, buzz, and so on. So yes, we have program FizzBuzz, and then we have a do statement, and the do 40 is saying when you get to line 40, loop back to here. There's no begin, end, or anything like that. And then I equals 1, 20, numbers from 1 to 20. And then at line 10, we say if the modulus of the number and 15 is not 0, then go to 20. Otherwise, print asterisk, 8H FizzBuzz. So the 8H says the next 8 characters after this are character literals, and you should just print them out. And then continue, which drops down to line 40, which then goes back up to the line at the start. And so we didn't have else, we didn't have then, we didn't have blocks or any of this sort of stuff. We had essentially a lot of go-to. This is factorial, I think. Yeah, probably. In FizzBuzz, in Fortran. And you can see here, so when they were writing the specification, they were using the multiplication symbol, which is not just a lowercase x, it is a separate symbol. And then when it came time to actually start writing programs, they went, oh, hang on, the teletype machine that we're using to create punch cards doesn't have a multiplication symbol. What shall we use instead? And so they went for the symbol that was on there that looked the most similar, which was the asterisk. The other fun note with Fortran is it was all programmed on punch cards. Anyone ever done punch card programming? There's like sometimes, yeah, just some of the much, much older people in the room. But yes, so a Fortran punch card had 80 usable columns, 80 columns that you could actually put program code in. And there was no line continuation. So the maximum length of a line of code in Fortran was 80 characters. And then on teletypes, the maximum width of the teletype was 80 characters. And on the first dumb terminals that people attached to computers, the maximum the width was 80 characters. And then when you started to get graphical user interfaces and editors like Notepad++ and all those sorts of things, for a very long time, the default word wrap width was set to 80 characters. Even when we started to get wide screens, you'd have to go, no, I want to make it like 140 or 180 or whatever. And that 80 character limit comes all the way back to these Fortran punch cards. So yeah, Fortran gave us if statements, but not else statements, or then, or anything like that. It gave us the asterisk for the multiplication operator. And the other thing it gave us is I as the iterator variable. So when you write a for loop to go through an array and do things, you say for I equals 0, I is less than array.length, I++. Why I? Why not A, or X, or N? Fortran had 2 data types, integer and real. Most of the time, people wanted real because they were working with trajectories and physics simulations and weather prediction and all this sort of thing, and so floating point numbers were much more useful for that. If you wanted an integer variable in the very first version of Fortran, the way you told the programming language was you made the name of the variable start with I, J, K, L, M, or N. And so out of those, if you want just the simplest one that you can think of, it's just the first one, it's just that character. And so Fortran used I as the iterator variable, and then every programming language since then that I am aware of, that continues to use I, and that's why. A later version of Fortran introduced variable declaration with types, which led to the fantastic Fortran joke, God is real unless declared integer. Yeah, Fortran jokes. Anyway, Fortran's out there. Then this guy comes along. This is Edgar Dijkstra. And he is most famous for this one thing. I actually got picked up in a code review the other day because I used a goto, because it's there. It's C# has goto, and sometimes it's the easiest way to break out of three nested deep loops and everything. But he said goto considered harmful. He said a lot of other stuff as well. He said things like basic causes brain damage. But my favorite one of his is, if debugging is the process of removing bugs, then programming must be the process of putting them in. And Dijkstra advocated the idea of structured programming and blocks and scope and things like that, and functions that could call other functions and all this sort of thing. And those ideas were put into Algol. Now, I've put Algol 1958 here, and there was an Algol 58, but it was a very, very theoretical language, and one of the things that it didn't have, because it was experimental, was output. And so you couldn't write FizzBuzz in Algol 58. You had to wait until Algol 60, which then added output, and then you could write FizzBuzz in Algol. And you can see here we've got a begin and an end at the start and end of the program, and then we declare a variable and we give it a type. And then we say for I equals 1, step 1 until 100, which is, it's a for loop now. It's not just a do loop. And then within that, we have begin and end, so we don't need line numbers to say we're going to jump to here. And then pretty much the same as Fortran. We have an outstring function that writes out to the standard output. And we have if, elif, elif, else. The other thing that was created as part of the Algol project, one of the people on the committee, and it was a committee that created Algol, was John Backus. And having created one programming language and now being involved in the creation of another, he started to think there should be a standard way to notate the syntax and rules of a programming language. And so he created what was originally called Backus Normal Form. And there was another chap on the committee whose first name I can't remember, but his last name was Naur, N-A-U-R, and he suggested some improvements, and it became Backus Naur form. So BNF, the grammar that we use for defining programming languages and syntax, which here is showing Algol's for loop syntax, and here is showing JavaScript's iteration syntax, and it's the same. It's the same thing that we still use today. Nobody has come up with a better way. So Algol gave us block structure, it gave us if, then, else. It also had switch statements, it had for loops, functions, semicolons at the end of lines, which I'm sure are all us C-style language, room full of Java developers, and I'm down here going C#. C#, it's valid. And wearing a .NET t-shirt under this one. So, But yes, and an Algol derivative gave us another thing that I'm sure everybody is incredibly happy about, which is null. So Algol.W was the first programming language that introduced the concept of records, or like structs. And when you have records, which have like a first name and a last name and whatever else, you need a way to indicate the absence of a record. So not having a middle name you can represent with an empty string, but not having any children, for example, you have to represent that as a null. So this is what the null looked like in Algol. W. Same time as Algol, John McCarthy was at MIT working in the AI lab at MIT, and this is John McCarthy, and he wanted a programming language for building artificial intelligence, building expert systems and that sort of thing. And there was a lot of work being done at the time trying to model how human brains work and process information. And the best they came up with was that we have lots of lists of information in our heads, and we find relationships between those lists. And so he decided that what was needed was a language that was dedicated to processing lists, and a list processor, if you will, or Lisp. And this is FizzBuzz in Lisp. And You can figure it out. It sort of makes sense. You've got the function FizzBuzz, and then you say you've got a loop for thing, and then we say, is it divisible by 3 if mod n and 3 is 0, then divisible by 3 becomes true, and divisible by 5 also becomes true of the other thing. And then we go down into our cond statement here, and cond statements in Lisp. If the first thing in the list is true, then the rest of the list is evaluated. Otherwise, you go to the next thing, and so on and so forth. And then we have 6, 7 close parens. This is how you can spot Lisp programmers as they're sort of going down like they're writing code. They're going 8, 8, 8, 7, 7, 7, 7, 6, 6, 7, trying to work out how many close parens they need at the end. My other favorite thing, has anyone done Lisp programming or scheme or closure or any of that sort of thing? So you know car and coulda? So car gives you the first element in a list, and coulda gives you the rest of the list, CAR and CDR. Still there today in Scheme, in Common Lisp, and in lots of Lisp derivatives. And where that comes from, so the first version of Lisp was created on the IBM 704, and the IBM 704 had 36-bit registers, because there was no kind of 8, 16, 32 in those days. It was just an absolute free-for-all. And so you could store information in this 36-bit register. This is what it looked like. You had a prefix, which was the first 4 bits, and then you had the decrement register, and then you had a tag, which was another 5 bits in the middle, and then you had the address register, and then you had a bit at the end there as well. And so I think I got it the wrong way around, actually. It might be car is the rest of the list, and coulda is the first item in the list. But anyway, so coulda stands for content of decrement register, and car stands for content of address register. And this is my favorite example of an implementation detail of an original design, then spilling over into every subsequent implementation long after the decrement and address registers were consigned to the dustbin of history. But Lisp gave us first-class functions, so functions that could be passed as parameters to other functions. Also, because of the way it was allocating memory and the way it was dealing with lists, it couldn't just work on the stack, and so they had to invent the idea of the heap, which meant that Lisp was the first language that had something resembling a garbage collector. I mean, it was much simpler than what we know as garbage collectors these days, but it was sort of garbage collection. It even sorta, kinda, a little bit did just-in-time compilation, but we will come back to that later on. Algol gave birth to Simula. Simula was created in Oslo in 1962, and Simula was the first object-oriented language, not Smalltalk, not C++, not any of the others. It was Simula. And this is FizzBuzz in Simula. So we have a class printer, and we pass in an integer, and then the text to print if the number is divisible by that integer, and then another integer, and then the text to print if the number is divisible by that. So here we have kind of like a FizzBuzz abstraction. You could make this do like 4 and 7 if you wanted to, and you could make it print like lemon and aid or something instead. So yeah, proper kind of abstraction things going on here. So Simula gave us classes and inheritance and polymorphism and the idea of scope, the idea of whether a field in a class is visible outside that class or visible to descendants of that class and all that sort of thing. All of that was in that very first object-oriented programming language. I love this one, APL. Has anyone done any APL programming? It's completely brilliant. It was invented by this guy, Kenneth Iverson, and he conceived of it as a teaching language. He was teaching programming, and he wanted to teach it at the kind of most fundamental level, understanding algorithms and data structures and working on those systems. And the really clever thing with APL, and there are still people using it today, and there are derivatives. It's used a lot in finance for writing the sort of things that quants write. And APL could work on every element of an array at once, and the compiler would take care of parallelizing and all that sort of thing. And that means that this is FizzBuzz in APL. That's the whole thing. That is the entirety of FizzBuzz in APL. Most of it is actually the words FizzBuzz, fizz and buzz. I mean, that's like half the code. And then the rest of it is just, hang on, that's not a W. I don't know what that is. And then we've got some numbers, and then we've got the W again, and then we've got a weird little sigil. So basically, APL is like a normal programming language, but with Elvish in it. And if you wanted to write APL code, you had to buy one of these. This is an APL keyboard. And I think this is genius. I assume Kenneth Iverson was selling these for like 500 quid a pop or something. And going, it's necessary if you want to pass my course. All right, then here's the 500. I'm going to do this one day. I'm going to create a programming language that's just emoji. And then you'll have to buy emoji keycaps to make it work. But the thing that APL introduced that continues on in JavaScript is dynamic typing. Because an array in APL, it didn't have a type. You could put whatever you wanted in each element of an array. You'd sort of assumed that they were all the same, but if you wanted to make sort of half the array numbers and half the array strings, you could absolutely do that, and your program would crash accordingly. During the 1960s, there were various attempts at improving on Algol. There was BCPL, the batch control processing language, CPL, which I think was just the control processing language, and then B, which was created by one of the guys who worked on Unix. And B looked like this. And so we have an import at the top there, and we have our for I equals 1 to 100 do, and we have let's start B to define a function, and so forth. And the really cool thing about B is, so this is where we get our they have no laser. But this is where we get our curly braces from. Okay, this was the language that introduced the concept of curly braces. Except, remember the thing with the multiplication symbol and Fortran? So the VT100 terminals that they were using at the time didn't have the brace character on them. It wasn't a thing you could type, and it wasn't in 7-bit ASCII. I think the brace character goes into 8-bit ASCII. And so if you were using one of those old things, you had to use $open paren and $close paren. And you can still see that today in PHP. Don't go looking at PHP. Nothing good has ever happened in PHP. But yes, BCPL gave us curly braces. And then, of course, C. So first proper programming language I learned that wasn't was like a Sinclair Basic or 6502 assembler, which I do not recommend. So yes, C was created in 1972 as the language in which to write the Unix operating system, and it was created by those same guys, and it led to this book, the C programming language. Who learned programming from this? Quite, yeah, we're getting there. People are starting to have been born. That's great. So yes, and the C programming language was the first book ever where the first program you wrote was hello world. It was just like void main printf hello world \n, otherwise the cursor would just stay at the end after you're done and people were and so yes, this is FizzBuzz written in C, and we have int main void and an int I, and we go through, say, for I equals 1 and everything else. Very simple C code there. The fun thing, though, is that this is also FizzBuzz in C, and that will do the same thing. And that is FizzBuzz in JavaScript. Yeah. Because C gave us the C style that we use to describe languages like JavaScript and Java and C# and whatever else today. And it gave us Hello World as your first program. It also gave us the concept of truthiness. So this thing in Java where something's either 0 or false or null or undefined, and if it's not any of those things, it's true. And C introduced this. You could say, like, while C equals getchar, and what it was returning back was an integer which represented a character, but it would evaluate that as an expression, and if it was greater than 0, then it would carry on round the loop. and obfuscating code for fun and profit. The International Obfuscated C contest every year is just, it's genius. I love it. Seeing it actually in the wild, though, not so much. I was once helping a friend who was learning C++, and they had an assignment, and it was validate an ISBN number. And so we worked through it and looping along and saying, so now we're looking for an alphabet letter and everything else. And then when we were done, I wrote the whole thing as a for loop with no body, and told her to hand both of them in. And she got full marks for it, and the guy said, don't let him help you with your assignments again. Fair enough. So yes, also in 1972, Smalltalk. Everyone knows about Smalltalk. Smalltalk was object-oriented. A lot of people think Smalltalk was the first object-oriented language. It wasn't. It was created at Xerox PARC, and it was primarily created to be the programming language for the WIMP GUI graphical user interface computer that they were building until somebody very ill-advisedly gave Steve Jobs a tour of the campus and went, look what we're building. And Steve went, oh, that's interesting. But yes, Smalltalk, it's very difficult to write Smalltalk these days, but you can find FizzBuzz in Smalltalk on the internet. And it's really interesting. Smalltalk, there is, people go, oh, what happened to Smalltalk? It became Ruby. And it lets you do all the terrible, terrible things that Ruby lets you do, including JRuby, like monkey patch existing types, and not just monkey patch them, but replace methods on existing types. And so when you write FizzBuzz in Smalltalk, you don't just create a function that takes an integer. No, you add a function to integer that will do the FizzBuzz thing, and then you can loop through it and say FizzBuzz display n directly on the integer. Smalltalk. So this is from the Wikipedia thing, this idea of everything being a class. All values are objects, classes are also objects, each class is an instance of the metaclass of that class. Metaclasses are in turn also objects and are all instances of a class called metaclass, which I'm guessing is an object. Code blocks, so Smalltalk's way of expressing anonymous functions, are also objects. Everything's an object. So yes, Smalltalk gave us reflection. This was the first language where you could actually reflect over the other objects on the heap at runtime and then invoke methods on them dynamically. And it gave us the console. So somewhere, because you were writing graphical code with it, you couldn't just print out debug messages anymore, and so they created a console that would write to a dedicated window on your desktop. It was the first language to use a virtual machine, so it didn't run directly on the underlying hardware. It had bytecodes and bytecode translation, which meant it sort of had the first proper JIT. I'm asterisking that to come back to it in just 1 second because it wasn't officially the first real JIT out in the wild. And this idea of everything being an object. So, bonus point question, who can tell me which language did have the first JIT compiler? Anyone got any ideas? I'll give you a clue. Regex, regular expressions. The first implementation of regular expressions in the I think it was 1968, and done at Bell Laboratories. The guy who created the regex implementation decided it was too slow, and so he wrote a JIT compiler that translated the regex instructions into raw machine code at runtime and cached them. This is FizzBuzz in regex, which I found on GitHub. And it's in a gist in GitHub, and it just has one note underneath it from the programmer. Yeah. I love the fact that those people are out there, and I love the internet for bringing them into our computers. So yes, 1973, the year I was born, and the year The Dark Side of the Moon came out. nothing else of import. But no, ML was created, and ML was the first functional programming language, or the first intentionally functional programming language. And so this idea of things not having side effects, and you put a value into a function, and another value comes out, and every time you put the same value into the function, the same value will come out at the other end, and all this sort of thing. And so this is FizzBuzz written in original ML, but if you look at like OCaml and F# and all those sorts of things, they are all essentially ML with bells and whistles attached. So this gave us first the arrow function syntax that we now have in JavaScript, although it did take a while to turn up. 1975, Abel and Sussman were teaching Computer Science 601 at MIT, and they wanted a simple programming language that they could use to teach the fundamentals of programming. And so they looked at Lisp and decided, it's okay, but which implementation should we use? And it's a bit complicated, and there's some stuff in there that makes things we want to teach too easy. So they didn't. It's like going into an interview question. They go, sort this list, and you go, list.sort. And they go, no, write the sort yourself. And you're like, yeah, I'm not working here. But they wanted to teach people to write list sort and everything else. And so they created a stripped down version of Lisp called Scheme. It was very, very simple. And by the end of the first semester of this course, you could actually write a Scheme interpreter in Scheme. And then you used your own Scheme interpreter for the rest of the. It was very, very meta and self thingy. Ouroboros, the snake. And so yes, this is FizzBuzz in Scheme, and it doesn't look that different from Lisp. It's essentially the same thing. It's just a more simplified version. You can still use Scheme to this day. I think it's called Chicken now, or Racket, or there's all sorts of different Scheme implementations. But yes, you can. Don't, but you can. Scheme didn't really add anything to the lexicon of programming language features at all. The reason it's in this talk is because when they went to Brendan Eich and said, can you add a scripting language to Navigator 2? We need it for a demo. When's the demo? Next week. He went, damn, I need to write a computer programming language really quickly. I better write a Scheme. And so he wrote a Scheme, and he did. And so JavaScript was originally Scheme running inside the browser. Document object model represented as a Scheme kind of nested list structure. And the thing they were competing against was Java applets. I do remember a guy in the office I was working in at the time saying, oh, come and look what I've done, come and look what I've done. And when you moved the mouse over a button, it glowed. And he'd written Java code, and there was a Java applet that was being downloaded and then loaded into the JVM and running inside the browser, and blah, just to make a button glow. And it's, these days it's weird to even think back to when we needed JavaScript to do that, because now it's just CSS styles. But in those, yeah. And so Netscape were competing against Java, and they went, well, you should make it look more like Java. And so JavaScript was born. But underneath, it's still essentially it was a Scheme engine for a very long time. So then Simula and C got together and had a baby, and not a pretty baby, not one of those cute babies where you go, oh, what's her name? One of those babies, there is no God. And, I say that. The guy who invented it also says that. C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. Still the dominant programming language used for systems programming and building operating systems and video games and everything else important in the world. And when we all die, it's almost certainly going to be his fault. This is FizzBuzz in C++. And when I'd been doing C for quite a while, and they went, learn C++, and the C out, less than, why? What was the rationale behind C out less than? What's wrong with printf? So anyway, that's C++. And the thing that C++ did invent, that we have in JavaScript and Java and all these sorts of things, was the whole concept of structured error handling and exceptions and try, catch, and throw. And so before that, you just returned usually an integer, and then you would say, if the integer is 0, then everything's fine, carry on. Otherwise, if the integer is various different numbers, we can tell from that what has gone wrong by comparing it to a lookup table of error codes. And so C++ went, sod that for a game of soldiers. You're just going to throw an exception and hope somebody up there somewhere catches it. And then Smalltalk and APL, weirdly, also got together and had a baby called Self. I had never heard of Self before I started researching this talk. Has anyone ever heard of Self? Yeah, nobody cares. It's just gone. But Self, it was really quite a clever thing. It was a lot like Smalltalk. It was designed for graphical operating systems. It worked in roughly the same way. You had components, but it actually represented kind of components and functions and everything as distinct objects that you could drag around on the screen. And this is how Self did object-oriented programming. Everything else uses class-based inheritance. You define a class, and then objects are instances of that class. Self does it this way, where you say animal equals an empty object, and then dog equals an empty object, but its parent is animal, and then poodle represents an empty object, but its parent is dog. And so when you instantiate an instance of poodle, it goes and it gets the properties and methods from dog, which then goes and gets the properties and methods from thing. And so you're essentially creating a copy of a prototype of each object. So this is prototypal object-oriented programming, which Self invented, donated to the world, and then buggered off and left us to deal with it. So yes, thank you, Self. And then in 1995, at the Sun campus, James Gosling invented, some god-awful language. What was it? I think it was Oak. I think he called it Oak. He actually did. He called it Oak originally, because there was an oak tree outside his room, outside his window, and it's just lucky it wasn't the toilets. But no, Java. He invented Java, and this is FizzBuzz in Java. That is the shortest way to write it. Yes, it is. Shut up. Yeah, no, that's just, you can do the same thing in C#. We just don't. So yes, and then all of these things, all of these languages came together to create JavaScript in 1995 at Netscape. And like I say, it was created. It was a demo. It was not intended to be production quality. It was just, hey, create a scripting language as a demo that we need this for next week. And so he threw it. I mean, all respect to Brendan Eich, that is a hell of an achievement. But they say if you could use a time machine, what would you do? Would you go back and kill Hitler or Genghis Khan or whatever? I would just, why is my battery running? That's because I haven't plugged you in. Caught that just in time. Now I've pulled it out of the other end. Talk amongst yourselves. Yes, I would go back in time to 1994, and I would say to Brendan, I would find Brendan Eich, and I would say to him, in a year, Mark Andreessen and the other guy are going to come and they're going to ask you to write a scripting language to hook into Netscape Navigator 2.0, and I need to tell you that it's going to become the most widely used, the most dominant programming language in the world. So here are a couple of requests. Make it statically typed. Make it understand the difference between an integer and a floating point number. What else could we just, there's lots of stuff. And classical object-oriented rather than prototypal. You can't do classical in Scheme. The reason that JavaScript used prototypal inheritance is you can implement prototypal inheritance in Scheme. You can't implement classical inheritance in Scheme. And so that's why we have prototypal inheritance. But yes, JavaScript came along, and then other languages have come along since JavaScript. My personal favorite is Hello? C#, which was invented in parallel with Java, completely separately, wasn't inspired by it at all, definitely wasn't just because Sun wouldn't license Java to Microsoft and let them create their own thing called Visual J++. No, it was based on C++. It's actually C++++, and what you do is you take the second two pluses and you put them under the first two pluses, and then that makes the hash symbol, and that's why it's called C#. And yeah, completely unrelated to Java and vastly superior in every way. Mark attempting to get himself tarred, feathered, and booted out of Antwerp on a donkey. But no, one of the nice things, though, about C++ is that Microsoft continued to develop it and invest in it, and Oracle bought Java and then tried to use it to sue Google, and then it was only when that failed they went, maybe we could actually make Java better too, and so now Java is also evolving at this kind of geometric rate and getting better, and I will happily use either language, to be honest with you, or Kotlin. Seriously not Scala, though. That scares the crap out of me. But C# has introduced things to the world as well. And one of the things that C# invented was async await, which has now gone into JavaScript, and we have promises, and you have async methods, and you can await things inside async methods, and all this sort of thing. And JavaScript continues to evolve. We continue to get new features. They're currently talking about putting gradual typing or type hints into JavaScript so that you can say, just don't pass anything that's not a string to this method because I'm going to do string things with it, and if you pass me a customer object, I will explode, and so on. But yes, so it's lots of, I think my point, the summary of this talk is that JavaScript is this coming together of things that were invented as far back as 1955, a full 70 years ago. There were decisions that were made then that are still in JavaScript today, and in Java, and in C#, and in whatever programming language you create. You will never create a programming language that is not in some way influenced by Fortran, because just the idea of there being a programming language comes from Fortran. And then you've got Algol, and you've got Lisp, and Scheme, and ML, and all these different programming languages that have gone along the way. And every single one of them has had something that's gone into JavaScript. However, there are programming languages that, because people come up to me, one of the questions I get is, why not COBOL? And the reason why not COBOL is there's nothing in COBOL that anybody has ever put into any other programming language, because COBOL is nothing but 8 binders full of bad ideas. Seriously, COBOL, the idea was we need to make programming more like English. And so the COBOL way of writing a multiplication is to say multiply A by B giving C. And then you have a variable called C, and you can do things with why? C equals A times B. You've been to school, you've done maths, you know what that means, But no, business people apparently forget maths as soon as they go into business, which would explain a lot. But no, so COBOL's not in here. Pascal is not in here because Pascal was just C without semicolons, random colons in various places, and begin end in squiggly braces. I remember we actually had an include for C that was just define macros, and you could run Pascal. You could compile Pascal just by switching out curly braces with begin end and that sort of thing. And yes, so if your favorite programming language was not in this talk, that's because it's crap and nobody used any ideas from it ever again. So yes, I do have 1 minute for questions. If anybody has any questions, see if I actually know what I'm talking about. Hi.
Why isn't BASIC in there?
Why isn't BASIC in there? Basically the same thing. BASIC didn't add anything. So it was a lot like Fortran. It had goto as its main method of flow control and go sub and that sort of thing. But yeah, BASIC didn't add anything that didn't already exist to the world that has then gone into JavaScript. What it did do, and We should thank the creators of BASIC and the creators of all those home computers in the 80s. It may not have inspired any programming languages, but it inspired a generation of programmers, and so I will give it respect for that. And that is essentially all we have time for. I hope that was interesting. I don't think it's particularly useful, but it's interesting. Nice change of pace. So I have been Mark Rendle. That is Alice, and Ganu Veg.
All systems are nominal. Initialize Genesis sequence.